How long have humans been thinking about aliens? Why is the Oort cloud a sphere when the solar system is a disk? And which space image is my favorite? And in our Q&A Plus on Patreon, is searching for life only limited to looking for water? Answering all these questions and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Paige Potter, what and when was the first conception of aliens that we know of? So humans have been thinking about aliens, like intelligent entities that don't come from planet Earth, for a very long time. And the sort of earliest recorded thinking about this actually comes from the Greeks. So thousands of years ago, people looked at the stars and thought about what if there were civilizations out there in the cosmos. The thinking didn't go very far because they didn't have a very good and accurate representation of what the universe really was. But even in the Middle Ages and once they started to give a thought about how the planets are just other worlds that are orbiting around either the Earth or the sun, people started to wonder about whether or not there could be other life forms out there that were different than, or maybe related, maybe different. The some more modern idea of aliens really started to come into hold when you think about, say, the turn of the 20th century. Percival Lowell was examining the surface of Mars, saw these strange canals across the surface of Mars, and imagined that there was some intelligent civilization, that their planet was drying up and they were attempting to move the water from the poles down to the equatorial regions and try to keep their planet alive. Probably he was seeing a lot more than what was actually there. And then you sort of go into that more modern age in the early, the turn of the 20th century into the 20s and 30s. You had all of this pulp fiction, science fiction. People were really starting to give us that modern conception of aliens. So people have been thinking about this idea for a long, long time. And it's only just been in our generation, in modern times, that we actually have the ability to search for them, that we can send spacecraft to other worlds to go and look for the canals and we don't find any, or descend through the cloud tops on Venus and find out that the place is a hellscape and not a lush garden. That we have giant radio telescopes that allow us to listen for signals from intelligent civilizations being beamed at us through space. That we can use telescopes to examine and sniff the atmospheres of planets orbiting around other stars, looking for the telltale signature of life on those worlds. So, it's crazy that we have been thinking about this idea for a long time, and it's only now in our lifetime and in the future that we will be able to practically answer this question one way or the other. Either, no, we're not alone, or yes, we are alone. But either way, it'll be interesting to find out. Paul in Tucson, how come the Oort cloud is a sphere, but the rest of the solar system, including the Kuiper belt, is on a plane? Right. So most of the solar system is on a plane which extends outward from the equator of the sun. And this is how the solar system originally formed. But then you've got the Oort cloud, and the Oort cloud is this largely spherical structure that is around the entire solar system. And so why? Well, it's because those objects are at the very limit of what is being held by the solar system, by the gravity of the sun. And so over time, they had all kinds of three-body interactions with each other, which allowed them to kick things into different directions while remaining just barely connected to the sun gravitationally. It wouldn't take much, a couple of kilometers per second, to escape from the Oort cloud, to move off into interstellar space. While, here on Earth, you would need an additional, 15 kilometers per second to leave the solar system from our orbit. And you're already going 30 kilometers per second. Like, you're going to use the Earth's orbital velocity and then an additional 15-ish kilometers per second to leave the solar system. But once you're out in the Oort cloud, it's hundreds of meters per second in delta V to get away from the solar system. And so they're not as bound as tightly to the sun. And the reason that we know this is because comets come from all directions. They don't preferentially come from the region around the where all of the planets are. Comets can come from any direction. And so that tells us that the Oort cloud is around us in a big sphere. So there's a whole bunch of questions about mapping the Oort cloud. This is interesting. So the problem is the Oort cloud is really far apart. Now there's potentially trillions of objects out there, but they're also very far apart. At that distance, things are going to be astronomical units apart. And so no matter where you go, you're not going to be able to see very many Oort clouds objects at the same time. So unfortunately, the best way for us to be able to see objects in the Oort cloud is to wait for them to fall into the inner solar system and turn into comets. And then we deploy an interceptor, some spacecraft designed to wait and loiter and watch the sky. And then some comet is moving in the right trajectory, or even an interstellar object, which would be even better. And then you calculate whether or not the interceptor has enough fuel to be able to meet up with that object. And then you fire it off and away it goes and does some kind of rendezvous with a comet or an interstellar object as it's passing down. And then you learn a ton about that. But no, it sucks, right? That the Oort cloud is this giant sphere containing, like I said, trillions of objects in this giant cloud. And yet we will never be able to directly image these objects because they're so far apart. And even if we try to go out to the Oort cloud, you're still not really that close to very much of the Oort cloud because it is such a gigantic region in space. It's time to shout out all the new $5 patrons and above: Stephen Greenhow, Maciej Jakowski, Isabella S., Astro Atomica, Charles, Michael Wegman, Ryan Reynolds, Daniel Verben, Richard Venice, and Lionheart. Join the club at patreon.com/universe today. Walter Hartman. So is dark matter and dark energy 100% real? We don't know what they are. So dark matter and dark energy are both separately a collection of observations about the universe, that the universe is doing things that don't match our understanding of the way the universe is supposed to work. The rotation speed of galaxies, the expansion rate of the universe. So for both dark matter and dark energy, there is a bucket of observations. So imagine cars are supposed to drive on the road, and every now and then you see a car fly. And it's like, it's not an airplane, just the car is flying. And you're like, did anyone see that car fly? And they're like, yep, I saw that car fly. And you're like, are cars supposed to fly? And like, no, cars aren't supposed to fly. How is that car flying? Okay, now the conversation can begin, right? Why is that car flying? Why is that car doing a thing that it's not supposed to do? We don't know. Maybe it jumped. Maybe it fell out of an airplane. So this is a terrible analogy. But the point is that astronomers have made a bunch of independent observations about the universe, and most of the time the universe does what it's supposed to, matches our understanding. Every now and then the universe does things that we don't understand. And so then astronomers are hoping to come up with explanations for why that is happening. And that there are specific things, with my car example, right? That there's certain things that you would immediately start to wonder and think, like, maybe it's this, maybe it's that, maybe it's this, maybe it's that. And so right now, both dark matter and dark energy are in the maybe it's this, maybe it's that phase of solving the mystery. So we know the thing is happening. There are observations that you can make with a small telescope that you can confirm dark matter for yourself. There are things you can do with looking through astronomical databases at observations made of Type 1a supernova, and you can confirm dark energy for yourself. You can do the math and look at the images of the cosmic microwave background radiation, and you can confirm both dark energy and dark matter for yourself. What is their cause? We don't know. And so right now we're in the phase where astronomers are considering every possible idea they can think of. So for dark matter, maybe there's an invisible particle that we just can't see that is lending its gravity. Maybe gravity works in ways that we just don't understand. Maybe our understanding of the laws of physics don't match. Maybe we made a measurement error for dark energy, right? Maybe what we think is actually an increased expansion rate of the universe is actually because we don't understand the way Type 1a supernova explode. Maybe there's a lot more material in in the galaxy clusters and the time dilation in those regions is throwing our measurements off. Maybe there's just measurement errors. Maybe there's like some kind of expansive force that comes from space-time itself. All of these are the theories that various people are working at and are attempting to narrow down and try to look for things that would then counteract those theories. You know, you're always looking to come up with some kind of way to know that your theory is wrong, because hopefully by the time you're left, the one that you have been unable to disprove is the one that best matches the situation. So the hunt continues, and it will probably take us a long time before somebody really figures out what is the underlying thing, or we may never know, right? But there are all of these mysteries that have been around that humanity's had to face, that for the people during that time, they didn't know the answer, right? Why is the sun so hot? What is it made of? People would do the math. Like, if the sun was made of wood, how long would the sun burn? If the sun was made of coal, what if the sun was made of oil, right? And it didn't work because it wouldn't last long enough. It was just a fire made of coal, wouldn't last. It wasn't until we learned enough about the way hydrogen works, when someone figured out fusion, that they finally had a viable explanation for the way the sun works. But you're not going to be like, you know, is the sun real? Yes. Is the sun a ball of fire in the sky? Yes. Well, you can't explain the sun, therefore the sun isn't real? No, the sun's right there. Everyone can verify with their own eyes. The sun is right there, is hot, it is doing its thing. And so that is the situation. Same thing. Anyone with a telescope and a willingness to do the work can confirm for themselves that these things are real. We just don't know what the cause is. Scotty-Too-Hottie, how long before the sun starts its evolution into a red giant? So the sun is 4.5 billion years old at this point, and so is the Earth. And it's estimated that the sun has about another 7 billion years to go. Could be a little bit less, maybe more, but it will eventually use up all of the hydrogen fuel in its core, and it will switch to helium. And when it does, it will go through a bunch of kind of death throes. It will heat up. It will sort of expand outward tremendously. It will gobble up the inner planets of the solar system, Mercury, Venus, maybe Earth. And then it will expand back down, and then it will grow again when it goes through another of these. It's called a helium flash inside the core. And so that's how long before the sun actually starts to get into its final stage as a red giant. And then it will eventually blow out all of its outer layers, and you'll be left with the core of the sun, the exposed core, which is what we know as a white dwarf. And you're like, well, great. You know, I got 7 billion years. I could do whatever I want. But the reality is that the sun is heating up all the time, very slowly. You know, not global warming heating up, but over the next 500 million to 1.5 billion years, people are still kind of working out the math on this. The temperature coming from the sun will heat up to the point that life on the surface of Earth will be unsustainable, that the oceans will boil, all of the water will evaporate into the atmosphere, the solar wind will blow the Earth's atmosphere off into space, the place will dry up, and that you will no longer have life on the surface. You know, there'll be no oceans. Now, you'll still have subsurface life, and that'll last right until that time when the sun potentially engulfs planet Earth. But, you know, the amount of time that we have to perfect our rocket technology is a little bit shorter. So, you know, we got to work on that more quickly. Heya Sasha, do you have a favorite space image photograph? I don't. Like, okay, there are like a lot of pictures that I think are great. There's a picture of Curiosity that was taken by the Mars Reconnaissance Orbiter spacecraft as Curiosity had deployed its parachute and was in the process of landing on the surface of Mars that I love. There's a video of the surface of Comet 67P. The one that the Rosetta mission went to. I don't remember how to say this word. I used to be able to say this. I can't even remember. Gerasimenko. Like, there's like a cliff and there's like snow and the mission is kind of rotating. And you like, this is a comet that you're seeing from the surface of. The pictures of the Apollo landing sites from space in orbit around the moon. And of course, pictures of nebulae, but nebulae and galaxies. And they all just kind of blur in my mind. I mean, every single day, I probably look at 10 space photos because I'm working on a story and we're including some pictures in the story. And I'm like, what's the best picture of a galaxy? What's the best picture of a nebula? I need a star cluster. I need an example of a dwarf galaxy. And all of these are just these incredible pictures that I am steeped in every day. And it's a good job, I gotta say. So unfortunately, I am so overwhelmed by awesomeness that I can't pick favorites. So yeah. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, do we really need water for life? Put a link in the show notes. All right, those are all the questions that we had this episode. Thank you, everyone who asked your questions in the YouTube comments, as well as everybody who showed up for the live show. We record that live every Monday somewhere on Earth, and I think the next one is going to be at 5 p.m. Pacific time, which is my time zone, but there should be an event here on the channel, and just make sure that you click the notification bell for that event, and then you'll get a permanent link to the episode, even when I then make it unlisted after we finish the live stream. So come check it out. It's 2 hours long. It's a great conversation. Lots of fun people in the comments. It's a great community. So come and be part of it. Now I'm going to give you another update on the media that I'm watching. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Barely Griffing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Balak, Cy Nielsen, David Giltonan, David Matz, Dustin Cable, Evan Pro, Greg Feely, Hans Schultz, Hudson Ward, Jay Graves, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Marcel Smith, Michael Purcell, Modso, Paul Robach, Ren Kaidu, Robeck, Sean Sargent, Stephen Fowler Munley, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So it's been a really good time for television recently, and I've been watching a whole bunch of things. Now, things that I've been preparing and telling you about that have finally come to pass. So the first one is that we just saw the end of Andor season 2, and it still was fantastic right to the very end, and is by far now my favorite thing that has ever happened in the Star Wars universe, including Star Wars. And it has elevated Rogue One to an even better movie now that you watch it in context with watching Andor. So if you haven't watched Andor, if you're like off Star Wars, give Andor a shot and then watch Rogue One after you finish watching Andor, and then never watch another Star Wars thing again, unless I tell you. You're perfectly fine to skip all of this other stuff, even The Mandalorian. But Andor is top-notch entertainment. The other new show that's come out is called Murderbot, and this is based on the Murderbot Diaries series. And I haven't read the books. My son has read the books and loved them, and so he's really excited that Murderbot has come out. There are 2 episodes on Apple Plus so far, and it's great. It's super funny, great sci-fi. I'm really enjoying it. Probably my favorite show is Love, Death, and Robots, and this is a series of short computer animations done where they tell sort of classic science fiction stories, short stories done by various writers. And the 4th season just came out, and it is just sadly so short. I mean, these things are 3 minutes long, 8 minutes long, 15 minutes long at the most. And so watching all 10 of them takes you about the length of watching a movie, but they are so delightful. Every one of them is so well done, and the previous seasons as well. So if you've haven't watched Love, Death, and Robots on Netflix yet, I wish I could go back, scrub these memories from my brain, and watch the whole series again afresh. There's just this big smile on my face when I'm watching new episodes. And then, of course, we're wrapping up The Last of Us, which has been going really well. And I haven't played the video game, and so I'm sure a lot of people I know are comparing their experience of watching this show compared to the video game. I've been really enjoying it. So if you haven't watched it, definitely check it out. All right, those were all of the media that I wanted to share with you this week. We will see you next time.